In this video, we're going to add and subtract radicals. If you remember our rules for adding and subtracting, we can only add and subtract like terms. So if you look at number 15 here, I would think I can't add and subtract any of this because nothing is the same square root. They'd all have to be like square root of 12 or square root of 48 in order for me to add and subtract them. So what I want to do is look at them and say, are they broken down into simplest terms? So the square root of 12, hopefully we'll start to have these memorized, because some of these are ones we see a lot, like the square root of 12 is a very common one. We are hopefully going to realize that that's 2 root 3. Where I'm getting that, though, in case you don't realize that, is when I list those factors, I circle the 4, square root of 4 times the square root of 3 is where I get 2 root 3. So that's one we hopefully come up with. Square root of 48 we just did on the same note sheet not too long ago. But I can redo it here. 1 and 48, 2 and 24, 3 and 16, there's my winner. Root 16 times root 3, square root of 16 is 4. So I'm going to replace that square root of 48 with the 4 root 3. Lastly, I'm going to try and break down 27. So 1 and 27, 2 does not go into it. 3 and 9, look at that. 9 is a perfect square. So I'd write root 9 times root 3, which gives me 3 root 3. So I'll bring my minus sign down with that, so it'll be minus 3 root 3. Now when you look at this, I can add root 3's to other root 3's. So I go ahead and add the outside numbers only. Think of this. This is the same type of problem as having 2x plus 4x minus 3x. If you were to do that problem, you would add the x's together and get 6x minus 3x, so your answer would be 3x. That'd be what you pick. Same idea with here. This root 3 is almost like a label to us. So I'm going to add the coefficients in front, the 2, the 4, and the negative 3. 2 plus 4 is 6. 6 minus 3 is 3. So my answer is 3 root 3. When adding and subtracting, your square root never, ever, ever changes. It's just like adding and subtracting variables. It stays the same. So you guys go ahead and try number 16 and then pause the video and we'll come back to that answer. Hopefully for 16, for the square root of 98, you got 7 root 2 because it's 49 and 2. Minus the square root of 72 would be 6 root 2, 36 and 2. And 32 is 16 and 2, so it would be 4 root 2. So when I add those numbers together on the outside, I'd have 7 minus 6, which is 1. 1 plus 4 is 5. So hopefully you got the answer 5 root 2. Number 17, this one just has a little bit more involved in it. So I'm going to break down each square root if I can. The square root of 3, I know that doesn't break down because 3 is a prime number, right? So 3 root 3 is going to stay. Square root of 72, I just did that one, didn't I? It was 36 and 2. So square root of 36 times the square root of 2, so that'd make this 6 root 2. And then I'm going to have a minus sign that gets brought down. 128, let me do that to the side here. 1 and 128. 2 and 64, there we go, 64. So it would be root 64 times root 2, which would give me 8 root 2. But then I have to take that 8 times the 5, so I'm going to get 40 root 2. And you can do all this coming down on your list, or you can go do it to the side like I am, however you want to solve that. 108, I don't know if we know that one, so 1 and 108, 2 and 54, 3 and 36. How's that sound? 3 and, no, not 36, 30, yep, 36, that sounds better. So here we're going to have the square root of 36 times the square root of 3. Square root of 36 is 6, so we'd have 6 root 3, but then I take that times that 2, so I have 12 root 3. This is our first one where we have different square roots in it. So I can only add the root 3's with the root 3's. So 3 root 3 and 12 root 3. Now we probably are looking for what we'd consider descending order with this. So should we write root 3's before root 2's or root 2's before root 3's? The answer is actually it doesn't matter. There's not a rule here because, to be honest, all of these numbers are just numbers. I could find the decimal value for all of these and really add them all up and get decimal values. We're just learning how to simplify with square roots. So you don't have to put them in a certain order. I tend to put them in the order they were given to me in, so I would do the root 3's first. But if you would have it in a different order than me, I'm not going to count that wrong. So 3 root 3 plus 12 root 3 would be 15 root 3. And then I'd add the root 2's. 6 root 2 minus 40 root 2 would be negative 34 root 2. So that's my answer. You also, if you did it differently, might have had negative 34 root 2 plus 15 root 3. These are both great answers. So you guys go ahead and try 18. Pause the video, do that one, and you can see if we get the same answer. So for 18, when I broke down the square root of 20, I got 2 root 5, which gives me 10 root 5 down here. Plus the square root of 24 would be 2 root 6, because I used 4 and 6. The square root of 180, when I break that down, that's actually 36 times 5, so it'd be 6 root 5. And then the square root of 54, when I break that down, I get 9 and 6, so 3 root 6. Then I have to take that times that 3, so it's plus 21 root 6. So when I add these, again, I like to add in the order I was given them, so I'll just do the 5's first. I would get 10 minus 6, which is 4 root 5. And then I add the root 6's. 2 plus 21 would be 23 root 6. And there's my answer. Again, if you happen to write 23 root 6 plus 4 root 5, same thing. You're good to go. Hopefully that is a good review of adding or learning maybe of adding and subtracting radicals.